9. If you enter there, any links, any slides, anything that will be shared in today's session will be available for you there, so you don't have to copy them off the screen or anything. And then lastly, if you wanted to turn on your captions, if you just click those 3 buttons on the top toolbar, it'll turn on captions for you so you can follow along with that as well. Okay, yeah, thank you, Christopher, for adding that in the chat as well. And then lastly, I just wanted to quickly go through our code of conduct. We don't have to go through the whole thing, but in a nutshell, it basically just means make sure you're being respectable in the chat, and as you're associating with other attendees or our speakers, just be kind and considerate. That's really it in a nutshell. I'll leave it up for a second on the screen. Perfect. So without further ado, I'll just hand it over to Christopher to take it from here. Thank you, everyone.
Thank you. Hi, everybody, and welcome to yet another session in this Green Tech series. And today we will talk about using software for sustainability. My name is Christopher and I will quickly introduce myself and I will tell you a little bit more about me later on in the presentation. For now, I'm a startup developer advocate working at Microsoft. And few other housekeeping items. As my colleague said, you will have access to all the slides and all the links I will show you during this presentation. And feel free also to ask any question you may have directly in the chat if it's during my presentation. And we will also have something like 15 minutes at the end of my presentation to talk together and to answer any remaining questions. So if you watch previous episodes in the series, you may have heard already about sustainable software. Today we will talk about something which is slightly different, which is software for sustainability. So before jumping into that topic, and I will tell you the story of a project I'm working on for helping sustainability. Let's talk about what is a sustainable software so you can understand the differences between these 2 different topics. So sustainable software is basically a mindset and a set of principles that developers, architects can use while they're creating their software to take into account the environmental impact of the software we are creating. So if you want to learn more about this topic or discover what sustainable software is about, my first recommendation for you would be to go to this website, which is the Principles of Green Software Engineering. This is a very simple website where basically we're explaining 8 different principles for creating software that knows the impact they have on the environment. And to give you some concrete examples, for example, we have carbon intensity. Depending on where your application is running and what kind of power is actually generated to fuel these servers, the carbon intensity will be different. For example, if you are running your server in the day within a country that has a lot of solar energy, then probably the amount of energy coming from renewable energies during this day is important. But at night, maybe the specific country is leveraging other sources of power that may have a higher carbon intensity. So maybe you can take that into account while designing your software. And for example, maybe running batches overnight is not the most sustainable way of doing it. And maybe you need to run this intensive computation during the day to benefit from renewable energies in the system. Networking is also a huge one. When we look at the overall energy consumption of an application, networking can represent a high amount of energy consumed by the applications. And you, as a developer or as an architect, you can do a lot of different things to reduce this networking consumption. It could be doing caching, leveraging services like CDNs. You may have heard of CDNs this week. due to a huge outage we had on many internet properties this week due to CDN. But most of the time, CDN are actually very helpful, both for your scalability and also for energy consumption. And I just wanted to, maybe these 8 principles seems a bit abstract or a bit complex to implement, but I wanted to show you something that is a tool that we'll almost all have, at least if you're running Windows 10, is the Task Manager. And in the latest version of Windows 10, within the Task Manager, you can add new columns to show you the power usage and the power usage trend of any process running into your application. And if you're a Windows developer creating a Windows desktop application or a web application, we even have other tools to help you understand the power consumption of your specific application and where does this power consumption come from? Is it from using the memory, using the disk, using the CPU, etc.? So in a nutshell, doing sustainable software is basically crafting a software or crafting an application that knows how much energy it consumes and what is the impact on the environment, and trying to adapt these code techniques or these architectures to reduce the amount of energy and the amount of impact we have in the environment. So now let's switch to software for sustainability, which is a different aspect, which is basically creating a software that directly helps people working on sustainability issues. So when I introduced myself to you, I was a startup developer advocate at Microsoft, but it's only half of me. The other half is spent underwater. I'm a scuba diver, scuba diving instructor, marine biology instructor by night, and I'm diving around the globe for more than 20 years. And during all these dives, I've been the unfortunate witness of a lot of pollution happening in our oceans and around the oceans. I think we all went to a beautiful beach somewhere, and we all have spot some plastic or some soda can in these areas. And this is one of the major issues we have regarding the oceans at the moment. About 2 years ago, I met some folks from the Surfrider Foundation Europe. So you may already know Surfrider Foundation. It is a non-profit organization that fights for protecting the oceans, and they are doing a few things. One of them, and they are quite well known for that, is for organizing trash collection days. So they have chapters all around the world, and they're organized multiple times a year, a group of volunteers to go on a specific place and to try to grab as many trash as they can in a morning or in a day. And I've discussed with the team at Surfrider about the most impacting issue they had and what they are trying to do to reduce this marine pollution. And they told us something that is really eye-opening, at least for me. You all know, and we all have seen a project in the news of some very futuristic boats that try to collect plastic into the oceans, or small water drones that also try to detect trash and to capture it into the ocean. The fact is, the oceans are the biggest thing we have in Earth, and they are immense, and it's very, very difficult to collect any trash when they are into the ocean. And one of the statistics they had at Surfrider from one of their studies is that 80% of the marine plastic pollution actually came from the rivers. And even if the rivers can be immense, and we will see that in a minute, it's much more easier to trap any plastic at the river level instead at the ocean level. So a few years ago, they launched a map project, and the idea is to basically create a map of the plastic pollution within the rivers. And when everybody will have access to this data, we can take further actions to reduce the import of plastic pollution directly at the source, directly at the rivers. So Surfrider, about 4 years ago, they started to create this map. And they've done it in a very hacky way, in a very startup way, which is using kayaks. They assembled a team of volunteers. They took some kayaks and they went onto some rivers. And each time they spot a trash, they collect it, obviously, first. And then they write the GPS coordinate with a pen on a paper. Few months after that, they switch the pen and paper, which is very difficult to manage, as you can imagine, for an Android application, an open source application called OSM Tracker, which is an open source application to track things, and they have customized it to track the different type of trashes. But it was still very a manual process, having volunteers going onto kayak and trying to spot with the eyes any trash and then mark their position into this mobile application. And when I met Antoine from, as you can see Antoine on the screen, he has a goal which was mapping 100% of the French rivers within 1 year. It's an ambitious goal. And why within 1 year? Because they wanted to be able to update this map, to redo this map every year, to be able to understand if there is any changes happening between a year and the year after. So if they are, for example, doing some educational actions on a specific place in a specific river, they want to come back 1 year later and 2 years later and see if their actions have any effect into the number of plastic pollution in the specific area. So 100% of French rivers, what does it represent? It's a lot. We estimate there is around 270,000 kilometers of riverbank in France alone. And I'm not talking about Europe or other areas in the world. So it's a lot. And if you're wanting to do it with just some people in a kayak, definitely is something you will not be able to achieve. So we wanted to help them to scale what they are doing. And what they are doing is, as a scientific grounds, scientific roots, which is what we call the scientific observer. Basically, a scientific observer is a human person going into an area and observing things. Here we are observing trashes, but we're also using the scientific observer to, for example, try to estimate a population of a specific species in a specific area. So it's something there is a lot of application into biological and marine science way beyond this specific application of trying to understand the trash. And we, after a bit of thinking, we think about trying to scale this observer in two different ways. The first one is adding more observers, because when we joined the project, there was only a handful of Surfrider volunteers, and that's it. And it's very difficult to augment this number of volunteers because we need to train them to be an observer. Is not an easy task, and that's why we also wanted to get a more automated way to do this observer work through technology. So where did we start? We had an intuition that we could leverage AI to help in this job of the scientific observer, but we didn't really know if the context was good enough to be able to get good results with AI. So we decided to do a first proof of concept using AI to count trashes from an image. And our start was basically starting from nothing. We had less than 300 images which were unlabeled, which means that we just have a folder in a in an USB key with some images, and we didn't know if there is any trash on these images or what type of trash is in the specific images or whatsoever. So we had a bunch of images. Some of them have trashes, and that's it. They had no database, no infrastructure to train machine learning models, etc. No developers, no data scientists, and no drones as well. So the first step was to leverage a service, a AI service called Custom Vision, which is part of the Azure Cognitive Services suite of tools, which basically allows you to train a custom computer vision machine learning model without knowing anything about machine learning or without having any data scientists. Well, the only thing you need is a bunch of images, and even that you need a very handful of images. We can start with only 5 images by type of object we want to detect, which is way less than any custom vision model you want to build from scratch. So we've been able, within an hour, to upload 100 of images, to label this 100 of images, and even to test, to train this machine learning model and to test it directly within the browser without having to code anything. And after this first test, as you can see in the image, the AI is able to detect some trash here, and each rectangle you should find a plastic bottle. Obviously, the model is not perfect. We have a number of training data set that is too low to get a higher score, and this image is quite complex to count the number of bottle in here. But as you can see, within 1 hour, we knew that we can leverage AI to tackle this problem. So with that in mind, we went on to the next step, which was scaling this effort, not to a handful of pictures, but really building a system that will allow Surfrider to create this map for the entire rivers in France. And the fact is, the reality is a bit different from the images I just showed you. These are the type of images we need to label. So I will give you a little exercise, and you can answer in the chat if you want, about how many trash are you counting on. Just take the left image, for example. So I will leave you a few seconds to try to count the number of trash in the left image here, and after I will show you what I see with my trained eyes, and we'll compare the results. So while you're trying to, yeah, it's hard to see. 4, 3, that's really a difficult exercise because most of the trash I show you before in this presentation were clearly identifiable. It's a bottled water, etc. It's something with clear marks. But for example, here we have a fragment of plastic. In this case, it's quite a big one, but there are very small ones. And the fact is, a huge part of the plastic pollution we find in oceans are not in a well-defined, well-bound object. There is more, and fragments account for a high number of trashes. So let's go back to the picture and try to count the number of trash. The first one is this one is quite easily identifiable. There is a second one here, which is not an optic artifact. We can say so, but if we zoom onto the image, we can see that there is indeed it's indeed a fragment of plastic. There is a small one here, and there is other one, and one which is very difficult to spot is here. And it's actually a chain, a metal chain, like the one you can have to hook up your bike to something so it's not stolen. So it's also a type of trash. There is no reason in this bank river to have a chain. So if my memory is correct, there is 5 different trashes in the left image. So as you can see, reality is complicated when we want to count trashes, and that's why for a few years, Surfrider and other people in this area leverage a scientific observer, someone who was trained for detecting this, instead of leveraging automated solutions. So to be able to tackle this issue with real world application, like we want to make it something which is real world and not just a POC, we assembled a team of volunteers coming from other NGOs, but also from private companies that want to dedicate like citizen time. So they pay their employees, but their employees are not working for the company; they are working for this project. It's a case, for example, with Microsoft and myself and a few other folks at Microsoft, and also we engage with the Microsoft AI School, which is a school in France for training future data scientists. So all of these teams have been assembled in a truly open source team, and we tackle different issues in parallel. The first one was creating a bigger training data set. As I said before, we had only 300 images, and we need at least 10x this number of images to get accuracy, a better accuracy in our machine learning models. Then we want to move from this custom vision model to a custom AI model, because custom vision was great, but custom vision is only detecting images, detecting objects in a still image. And what we want to do is to count images. And the best way we have today to collect these images is to put an action camera onto the kayak, or leveraging a mobile application. So basically, we need to go from detecting object in a still image to counting object onto a live video. That's why we needed to create a custom AI. Then all of this works is here to be able to publicly share a map of the plastic pollution. So we need to create an open database of first the rivers. It's complicated to get all the river segments, even if there is already like OpenStreetMaps, there is already open databases about geographic items, but for rivers it's quite complicated. It is quite scattered if you want to do it at a country level or even at a European level. And obviously we need to have a way to share all the trash data we are collecting. And creating a mapping service. The idea here is maybe the database is good for example, other researchers, but if a local Surfrider chapter want to engage with the local mayor of a small village to change things in this village, we cannot just rely on just a database. We need to have like a UI, a very easy to use UI, and we need to be able to export some maps with some information that are relevant to a specific geographical region. So the first project we've released was a mobile application, and you should be able to download this Plastic Origins application on both Android and iOS devices. It's an application that allows mostly Surfrider volunteers, but basically anyone who wants to create an account can participate in that. And basically creating a tracking. So if you plan to go on a walk near a river, you can launch the application, click on start recording, and each time you spot a trash, you can mark it and obviously collect it. And you can take a picture of it, or you can take a video, and all of this information will be sent to us. The idea is to start creating this map, even if it's still very manual, and it's just a small evolution compared to the OSM tracker application they were using, but at least it's a connected one. So we start to collect data for our trash database, and B, we are collecting images that we can reuse for training a better AI after that. Next thing I wanted to show you, and again, I will give you a little game, again, trying to count the number of trash you will see in this video. I will stop there. I don't know how many trash you spot in this segment, but there were 5 different trash in this segment. And this video is the actual video feed of an action camera plugged into a kayak. And this is basically our first source of trash. What we want to do right now is to take this video and basically having something that automatically and automagically counts the number of trash and even classifies the trash. We want to know if we have seen bottles, cans, fragments of plastic, etc., etc. So this problem space is actually already known problem space in AI and in computer vision. It's called the multi-object tracking. And there is already practical applications. I will show you 2 of them in the sports area. So for example, here there is an AI that is doing object tracking onto a soccer ball, and it's widely used in all around the world. And this is another one where we are tracking different objects here, some athletes, to do a lot of different statistics around that. So it is something that is well known, but we will see that our specific Surfrider use case is quite unique and come with its own challenges that are mostly unsolved for now. So what I will explain right now is the current AI we have, and I will also later on explain the next AI we want to build. But you will see that we have already achieved something where we can count trashes over a video. So basically what we are doing today is a 2-step process. First, we are detecting objects in still images. And from this list of images and trash identified in these images, we do the multi-object tracking. So let's see a real example from the video I just showed you. So basically, first we have the video. The first thing we do is we extract images from this video at a pace of 4 images per second. Then we run a machine learning AI on this. If you're already savvy about this, we are running a faster RCNN with between 20 and 50 million parameters to spot different type of things in these images. And the result out of it is, as you can see, we have bounding boxes. So the algorithm detected from the still images that there is a trash in this bounding box, in this image is here, in this image is here, etc., etc. So when the AI has been run, we get a few things. We got the type of background, which is interesting because Surfrider is operating on the rivers, but also on the waterfront. So we want to know if the image we got is from an urban environment or a river environment or more an ocean environment. Right now we got three classes. We are in the process of changing this. The 3 classes that are detected by our current AI is bottle of plastic, can, and fragment of plastic, and the bounding boxes. And when we have done that, we run our multi-object tracking, which is basically an almost unsolved issue in computer vision with our current situation. Because multi-object tracking, the existing algorithm, tend to have some fixed limits. And one of those limits is having the camera in a fixed point of view. So the camera is not moving. Maybe the objects are moving, obviously, because we're trying to detect objects moving into a video feed, but the camera is fixed or is just rotating and we know what is the rotation, what the rotation is at any point of time in the video. But in our context, the trash is moving, obviously, because the camera is moving. Also, the camera is not fixed. So we are trying to count the objects with a very difficult context. So, for example, the football players in a football area are very contrasted between the grass and themselves. So it's easy to spot them. As you have seen in the previous images, spotting trash in this river environment can be very complex, and the camera is moving. And it's still a research area, and we even welcome a PhD student 2 months ago to work on this issue. What we are doing right now is we are doing basic multi-object tracking, which is basically we have an algorithm that take all these images and then compute trajectories of the different trash from one video point to another video point, and we count the number of trajectories. But it's not a great way of solving this issue, and I will talk about it a bit later. Another thing we've done is creating a website for collaborative labeling. We need to be able to label thousands of images. So labeling is, as I said before, basically we take an image and we draw a rectangle around a specific trash, and we say in this rectangle you can spot a fragment, you can spot a bottle, or you can spot another type of trash. So you can go over right now to trashroulette.com and help us label images. If you're doing so, please ensure you complete the tutorial. It's like 1 minute, but it explains how we are labeling our different data. And the idea is including everyone to help us get from the amount of images we have right now, which is around 5,000 images, 8,000 images, to a complete label data set so we can train our AI. And without having all these images labeled, we've already been able to create a first machine learning model that allows us to count these trashes over a live video feed. So as you can see here, you can see the rectangle drawn around the specific trash, and you can see on the top left of the screen the counting of the different type of trashes. So this is running almost live on a video feed. Right now the process is in batch, so we upload the video and the process happens in the background, and then we have the result video computed, and we can see the video. So the end goal is not to produce this video, it's just to produce the counting of the trash and to have it associated with a GPS position. But we are developing a few visualization like this to train other scientific observers, and also to test, obviously, to test the quality of our model. So if we go back to this specific AI, and also if we try to make a link with software for sustainability, which is what we are trying to do right now, we are building a software to help an NGO achieve some sustainability goal. And if we try to link this back to sustainable software, right now we are using a lot of power, a computation power, to just count objects. To recap what we are doing in the algorithm, we are splitting the video into still images. For every still image, we run a first AI model to try to detect the objects. And then from all this information, we are running another AI to compute the trajectories of these different trashes over the video feed. And then we have a next step, which is trying to discard certain trajectories. For example, if there is a kind of a blip into the video, we don't want to count a specific trash 2 times. So maybe 2 trajectories are in fact only 1, or there is a short trajectory and we need to discard it because it may be an artifact. So we are doing all of these things that are all consuming a lot of power, and what we want to achieve is just to count objects. So what we are doing today may help in the helping sustainability goals, but we are doing it in a way that is not really sustainable. So that's one of the reasons we want to create a less overkill AI. We want to create an AI that use a video feed in input and just count the objects without doing all of this different operation. The PhD student is working on this today, and what we need is right now is also to have more images labeled. And I saw your question, Nigel. I will give you the link to Trash Roulette at the end of my presentation. So this is one of our next steps, which is creating a better AI that consume less resources. But if we think globally about our architecture, as I said, what we are doing right now is we are taking videos with action cameras and we are uploading all these gigabytes of data onto Azure, and then we're using GPUs onto Azure to compute these videos, etc., etc. And again, if we look back at the principles, the green software engineering principles, when I told you how we have architectured this application, you can already understand that we are using a lot of electricity. We are using a lot of networking because we are uploading gigabyte of data and we are downloading maybe a few data as well. I didn't told you anything about it, but basically the AI is running as soon as you uploaded a new video. So we are not taking into account the carbon intensity or the demand shaping or anything else. So we are just running the algorithm right now, and maybe we can just wait a few hours so we can benefit from having more solar energy into the electricity grid. So this is all of the kind of things we are in our roadmap for the next months, is to re-architect all of these backend services to use less energy or to be more aware of the type of energy we are using. And also, as I said, having a better, less overkill AI that basically spend less CPU and GPU cycles to do what we want, which is just counting the objects. And when we will have achieved this, we will be able to open up other possibilities. For example, one of the projects I'm working on is what we call for now the Surfrider box. The idea is it's great to have some volunteers taking some videos from Kayak, or some volunteers using the mobile application to do the same with their mobile phones. But this is not really reliable if you want to scale this mapping across a huge part of any country. So what we want to do is to find a way to collect more frequently this type of data. And one of our projects is to create an autonomous box, which is autonomous in electricity, in computation, in AI, etc., with an embedded camera that we can fix on some bridges or on some commercial barges that probably are, going two ways across a specific river several times a month. So we can collect more regularly data about the same specific rivers. But for doing that, we need to be able to get a machine learning model which is much smaller. And also in the prototype we have, we are leveraging the Azure IoT technologies to, for example, connect these boxes to Azure through different type of networks, including 4G networks, but also 0G networks, or networks very specialized for IoT objects, and also to be able to remotely manage the AI running onto these objects. The idea here is we can train this AI in the cloud, and when we have a new version, we can just push a new version of the AI into all these Surfrider boxes we have deployed. So this is something we are currently building, and I hope within the end of this year we will be able to showcase the first Surfrider books into the real world. So if you want to learn more about the technical aspects of this project, everything we're doing is open source. So you can actually go to github.com/Surfrider Foundation Europe to get access to all the repos. There is a main repo, the Plastic Origin projects, that describes the project and describes all the different repositories we have. And we have a lot of different repositories. We have AI projects, we have mobile API backends. We have the Trash Roulette website. We have the AI, the multi-object tracking AI, which is also open source. So there's a lot of things to explore just if you want to learn about how we have created this whole ecosystem. I've just dropped into the chat the links to the slides, and with the slides, you will get access to all of these links I'm presenting. If you want to learn more about this project, you can go to plasticorigins.eu, which is like the institutional website about this project. And thank you. I hope I pronounce your name correctly, Meshari, for copy pasting the trashroulette.com website, which is where you can find the Trash Roulette website and help us label the images. If you want to learn more about sustainable software, I also encourage you, and you will find the link at aka.ms/quiz/slides to go on Microsoft Learn, which is a free website with a ton of learning content. And one of them is the principle of sustainable software engineering, which go over into more details about the 8 principles I talked about. So you can better understand what are the concepts behind this. And with that said, thank you for being here tonight. Feel free to ask any questions. You can write the question in the chat, and you can also open up your mic and ask a question. So I will just go over to see if there is any missed question during my talk. I don't think so, but let me check. So there is a question about self-driving cars. Yes, so self-driving cars, it's definitely an area of computer vision that is very active, and there is a lot of people and a lot of energy and a lot of money as well going into this search area. The fact is, not all of them, but most of the self-driving cars are also relying on other type of data. They are not just only using camera, but they are using, for example, some radars like the LiDAR to get some data around about the surrounding environment. This is not something we've explored yet, but it's something we had in mind with the Surfrider box. Obviously, for example, for an Android phone or an iOS phone, we can ask the people, for example, to have to add infrared lights or infrared camera or thermal camera around it to try to better detect the trash items. But is this something we can do with a Surfrider box? We can have a naive Surfrider box, which is just using a video feed, and we can have a better version of the Surfrider box using other type of sensors to try to better spot the trash in the environment. This is something we had in mind, and we may be able to prototype them in the next months. So another question from Geoffrey, was the video showing the trash being identified done in real time on a mobile device, or it was first uploaded to a server? This video was uploaded to a server. It says, so right now the AI we had has some requirements, power requirements for doing the inference that basically make it not suitable for doing inference in a mobile device. And this is one of our goals with the ongoing development with the current version of AI. And the question, what's the minimum resolution and frame rate for video to be considered reliable? So I need to double check, but for my memory, the frame rate is not really so important. Like even with a 10 images per second, we got quite interesting results. For the minimum resolution, I think all the tests we have done was with at least 720p videos. I'm not sure we've made some good tests with lower resolution, but it's mainly tied to two things: the type of items you want to detect, which again can very blend into the landscape. Like the trash item you've seen is the plastic fragments don't have any clear bounds from the surroundings, so they're very difficult to spot. And if we lower the resolution, we may have a lot of difficulties to spot them. And the other aspect is we are not really leveraging the full resolution because when we are posting the action camera onto a kayak, then you can see some water, and we may not detect some trashes in this. Sometimes you are seeing the kayak itself, like the border of the kayak. So there is the video resolution, and there is then the usable video portion, the video resolution, that is a little bit less. So we need some headroom to. We are not zooming into the video, but it's kind of what we need to do. Even if we're detecting the trashes on all the video, most of the time there is like some areas around the video that are not really useful because we don't have any trash in it, like the sky. We don't detect trash in sky, that kind of things. So I think I haven't heard about Litercoin project. That's interesting. So there is other initiatives that are trying to achieve what we are trying to achieve, and we are in contact, or we are collaborating with few of them. I don't know OpenLitterMap. I've just opened the website and the paper you shared. The only thing which is kind of weird is seeing blockchain associated with that. Blockchain is actually a very important issue regarding sustainability. And as I said, we are creating a software for sustainability. So creating a software that directly helps attaining a sustainable goal, but we are also trying to create a sustainable software solution. And this is complicated right now with blockchain. Well, we have a few minutes, so if anybody has any other question, please do not hesitate. And if not, thanks for watching this presentation. Do not hesitate to grab the slides or to play around with Trash Roulette and try to label some images. And you can also follow me on Twitter or ask me a question on Twitter if you want after this call. And obviously, you can follow the Microsoft Reactor community on YouTube, meetup.com, or Twitter. And I think there is next week there is another Reactor event in the Green Tech series regarding, if I'm correct, creating a greener Chrome extension.